So right now we're talking about our warm-up. On our first problem, Kevin, what'd you do?
I divided both sides by 3.
We divide both sides by 3, and we get x equals
9.
Okay, DeMarcus, what'd you do next?
For what, 2?
Number 2, yep.
You subtract 6 from both sides, and then you get x equals negative 11.
X equals negative 23, yep.
That's right, bad.
So 2 negatives, so it's going to be a bigger number there. Okay, Dante, you ready? Number 3, what are you going to do to get that x by itself?
Add 9 to both sides.
We add 9 to both sides, and you get x equals 29. And then Taylor, you ready?
Mm-hmm.
So what do we do on this one? Multiply both sides by 3, okay. Over here, these go away. Now we have 2x equals 3 times 6 is? Okay, what'd you do next? Divide by 2. X equals 9. You could have also just multiplied by the reciprocal, 3 over 2 at the beginning, but this is a nice way of doing it. I like it. Nice job, you guys. Okay, over here. Natalie, you ready?
Isn't it divide by negative by half of x?
You had the first part right. Divide by negative. When you can't see it, what's up front? 1. So I'm going to divide by both sides by negative 1. And that gives me x equals negative 4. Okay, so this is our bell ringer for today. I did not write the objective on our next slide, but the objective's up here. I can write it in our corner so that you have it. Our objective today is to be able or to use properties of equality and congruence. I'm going to use my congruence symbol and congruence. So for the first one on your thing, it says reflexive property, and then it says A and B. Underneath A, you're writing this one. Underneath B, you're writing this one. So the reflexive property of equality is AB equals AB. You can also see that the measure of angle A equals the measure of angle B. The reflexive property of congruence is AB is congruent to AB, or angle A is congruent to angle B. Notice when we're talking about equality with angles, we keep that measure out front, M of our angle A. And over here, when we're talking about congruence, we drop the measure. So I'm going to have you guys write that down before we bring up the ladies. We have our symmetric property. If AB equals CD, then CD equals AB. Remember, without the line on top, it means we're talking about distance. And then the measure of angle AB, or measure of angle A equals the measure of angle B. Then the measure of angle B equals the measure of angle A. So that's the one with equality. Notice they have equal signs. For the one for congruence, we see if AB is congruent to CD, then CD is congruent to AB. And we see if the measure of angle A is congruent to the measure of angle B. We're going to drop those little measure signs. You're just going to write if angle A is congruent to angle B, then angle B is congruent to angle A. Our transitive property of equality, if AB equals CD and CD equals EF, then AB equals EF. The same thing can be applied with angles. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A equals the measure of angle C, and you see the same thing being applied in the congruence below. So transitive property of equality, we see if AB equals CD and CD equals EF, then AB equals EF. And we see if the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A has to equal the measure of angle C. And then again, we see the same thing being applied in the congruence in part D. So right now we are going to talk about these, and we're going to decide which property we are using to describe or what is being illustrated in this problem. So our first one up, you see that you have ST, segment ST is congruent to segment UV, and segment UV is congruent to segment YZ, then segment ST has to be congruent to segment YZ. Which one is this? Is this reflexive, symmetric, or transitive? Has to be transitive. So next part is we write transitive property. So transitive prop of, is it congruence or equality? Congruence, and we determine that by the fact that they have the congruent signs. Our second one up, we have FG equals HJ, then HJ equals FG. Property, reflexive, transitive, or symmetric. So we see that symmetric. That was our second one. Property of equality. Can you see there's equal signs? And then our last one, you see angle C is congruent to angle C. Yep, reflexive. Property of not equality, congruence.
There's none on my paper.
Okay, so our first part we see in the diagram, segment AB is congruent to segment BC, and segment BC is congruent to segment CD. We want to show the equality of AB and CD. Our first step here is we want to show what we know first. You're going to rewrite this part. AB, segment AB is congruent to segment BC. And we know this because they are congruent segments. So you can write congruent segment, segs. And we also know this line here. BC, segment BC is congruent to segment CD. And once again, we know that because they're congruent segs. So congruent segments. After that, we are able to show that AB segment is congruent to CD. Which property let us show that? Which one lets us show that if AB is congruent to BC and BC is congruent to CD, therefore AB has to be congruent to CD? Yes, ma'am? Exactly right. Transitive property of congruence. Trans prop of congruence. And what do we know about congruence? If they have the same. So things that are congruent have what? They do. They have something. I can't hear you. What'd you say, hon? Same measure. Yep. So their measures are equal. And because we know they're congruent, that means that AB, the distance of AB has to measure the distance of CD. Okay, so we see in the diagram that N is the midpoint of MP, and P is the midpoint of NQ. We want to show that NP equals PQ. So when it says that it's the endpoint of MP, what does that mean about the distances of MN and NP? They're going to be congruent. Yep, so we can put that little tick mark here. We show that they're congruent. When we show that, we know that means that MN equals NP. And we knew this by definition of midpoint. We also show that P is the midpoint of NQ. So what does it mean for NQ, or not NQ, NP and PQ? What do we know about those two if P is the midpoint? Yes, sir? Yep, that means they're also equal. So we show that by little tick marks. When you already have tick marks in the picture, you can create these little V's. So that way you can distinguish between them. So two tick marks that touch. And we see that we have NP equals PQ. And once again, that's that definition of midpoint. Okay. So, which property is going to allow me to say that MN equals PQ? Heard somebody say something, but I just couldn't hear what it was. I'll move back up front so I can hear. What'd you say it was? So if MN equals NP and NP equals PQ, we can say that MN equals PQ. So this is the same one we started here. Taylor's height equals Jasmine's height. Jasmine's height equals Natalie's height. Therefore, Taylor's height equals Natalie's height. Which property was that? Which one?
Trans.
Yep. Transitive property of? Do we have a congruent sign or an equal sign? Yep, so we're going to use equality. So our first one is the addition property. Adding the same number to each side of an equation produces an equivalent equation. So I'm going to give you an example of that. You see, I'm just going to write them down here. Example, x minus 3 equals 7. If we added the same thing to both sides, I'm going to add 3. If you add 3 to both sides, how would we get rid of this 3 if we wanted to? We subtract it to this side, right? What would happen over here? This would turn to? Just go to 0, because positive 3 minus negative 3 give you 0, and we're back at our original equation. So when we add the same thing to both sides, it's the same thing as our original equation. The same thing can be said about the subtraction property. Subtracting the same number from each side of an equation produces an equivalent equation. So here we ended up with y plus 5 equals 11. I'm going to erase that little line there, 11. So we see if we have y plus 5 equals 11, and we subtract 5 from both sides. If we wanted to get rid of this negative 5, what would I do to it? What's the opposite of subtraction? So we'd add 5 to both sides. When we add 5 to both sides, this one goes away, this one goes to 0. We end up with the exact same equation. So you see, if you subtract the same thing from both sides, you get an equivalent equation. Okay, so our first one up, we have the multiplication property. Multiplying each side of the equation by the same non-zero number produces an equivalent equation. So we see here, if you had 1/4 z equals 6, then if we did 1/4 z equals 6, if we multiply each side by 4, if I wanted to get rid of this 4 over here and move it to the other side, what would I have to do? We'd have to divide by that 4. If we divide by 4 over here, 4 divided by 4 is 1, right? So it's the same equivalent equation. So if you multiply on both sides, that means same thing on both sides. It produces an equivalent equation. And you see once again that the division property, dividing each side of an equivalent equation by the same non-zero number produces an equivalent equation. So if we're dividing, and then you have where you 8x equals 16 divided by 8. If you wanted to get rid of the 8 in the denominator, you can multiply 8 on both sides, and you see the result in the exact same equivalent equation. So substituting a number for a variable in an equation produces an equivalent equation. So angle 1 and angle 2 are both complementary to angle 3. We want to show that angle 1 and angle 2 are congruent. So our first step is we want to show what's complementary. What does it mean to be complementary? 90 degrees, yep. So we're going to do the measure of angle 1 plus the measure of angle 3 equals 90. And we know this by definition of complementary. We also know that the measure of angle 2 plus the measure of angle 3 equals 90 degrees. And by that same definition, def of comp. So these, it's important to put that justification off to the side so I know that you know how you're using it. At this point, our ultimate goal is to show that these two angles are congruent. We need to get rid of that angle 3 and the 90 degrees. Our easiest way of doing that is setting those two equations equal to each other. Since they both are equal to 90 degrees, we can rewrite it as the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. And we did this by substituting. So we substituted. Okay. At that point, yes, ma'am?
Well, in every test and stuff, do we have to write how we know it?
You have to write how you know it. And it's either going to be by property or by definition. Yeah. Because eventually we're going to get to our last chapter in our first semester, and it's going to be formal proofs. So at this point, we're just building up to that. So we want to get rid of angle 3. How do we get rid of the measure of angle 3? Yep, exactly right, Taylor. We're going to subtract it. Measure of angle 3, we're going to subtract it from both sides. When we do that, we see that this side, measure of angle 3 goes away. This side, the measure of angle 3 goes away. We're left with the measure of angle 1 equals the measure of angle 2. We're close to what we want, right? But we want to show that they're congruent. We know angles are congruent when they have what? We have the little thing, but they also have the same, what'd you say? Measure, exactly right. So we see that they have the same measure. So therefore, we can put the little line above it. We just drop the measures apart. We do angle 1 is congruent to angle 2. Here I put subtraction next to it. Subtraction, because that's what we did. And then here, I just put definition of congruence. Because you knew it by the definition of what it meant to be congruent.